Okay. Today is 9/21. And let's do a few problems. We'll start with r equals cosine 2 theta. Depends if you want a half a pedal or a full pedal. Each half pedal is pi over 4 radians. Okay? If you have r equals 9 theta, you have to convert to rectangular, replace the r with the square root, the theta with the inverse tangent. Now, we want to find the area.
Is half a pedal always pi over 4? Like, is that per
Oh, no.
Just in that case?
Just in that case, yeah, just in that case. Because there'll be, yes, different, each case would be a little bit different. This one here, for example, would be a little bit different. If you, okay, 3 theta, 3 pedal rows, okay, because it's odd, you got 3 pedals. We want the area of all 3 pedals, the sum.
Just one pedal.
Oh, just one pedal, okay. So let's see what we got. Start at 0, you get r is 0 when theta is 0. As theta increases, r will increase. Okay. We want to get it back to 0 again to find one pedal. Okay, so we want to get back to 0 again. So when is this equal to 0? This is equal to 0 when the 3 theta is equal to pi. And theta is pi over 3. At theta equals pi over 3, this is when it will hit the pole again. It'll start at 0 and hit the pole again at pi over 3. So the area of that one pedal is going to be equal to 1/2 0 to pi over 3, and pi over 3, by the way, would be the tangent line to the graph at the pole. Theta equals pi over 3. That theta equals pi over 3. 60 degrees, that angle, okay, is the tangent to the graph at the pole. Whatever causes it to be 0. You've got a tangent line at 0, theta equals 0. Okay, this one here, and you've got one at pi over 3, this one here. R squared, so we get 2 sine 3 theta squared d theta. And they want an actual answer here? Okay. On the test, if I were to ask you this, I'd ask you to set up the integral, okay? It's good practice to do these integrals, though. So here we go. You ready? So we end up with a 4 that I take out. Is everybody okay with this? Yeah, I just asked for the integral. I won't ask you to do it out. Okay. Everybody okay with this now? Hey. What's this, a new chair? Yes, I think it is a new chair. Wow.
So that's nice as the first one?
Oh, this is good. This bounces and everything. Wow. And it has a place where I can put my feet. Wow.
Nice.
Z is good. Z is good. Okay. So let's square the 2, 4, bring it out front, times 1/2 is 2. So I'm going to rewrite this as 2, the integral from 0 to pi over 3, sine squared 3 theta, d theta. Well, let's do it out. How do you integrate sine squared? What do you have to do? Half angle substitution. Let's do it. Half angle substitution for sine squared is 1/2. Okay. 1 minus cosine 6 theta. This is double what you had before, okay? And it's 1/2, 1 minus 6 cosine 6 theta. These cancel, so you get the integral from 0 to 3, or pi over 3, 1 minus cosine 6 theta. And we can integrate this. 1 d theta is theta. How do you integrate cosine 6 theta? Cosine u is 6 theta, du is 6 d theta, multiplied by 6 and by 1/6. Cosine u, the integral is sine. Wait, how come you said 2 substitutions?
I used US 3 theta. I started from the first. I think so. I don't remember though.
Oh, okay. Yeah, there's only one. As long as it's only sine squared. It doesn't matter what this the 3 is in front. Okay, so you get 1/6, and this is 0 to pi over 3. So we'll get pi over 3. Well, let's see what happens here. 6 times pi over 3 gives you 2 pi. Sine of 2 pi is 0. Substituting 0, you get 0 and 0. Pi over 3 should be the answer. Okay, that should be it. Do you have a way of checking it? No, huh? Oh, you do? Oh, rats. I mean, oh, good. Yeah, go ahead.
A quick question about this problem. Where does the 6 come from? From the 6 cosine 6 theta?
Right, this 6?
Yeah.
This 6.
Yeah.
Doubling this. The half angle substitution for sine squared is 1/2 the quantity 1 minus cosine 2 theta, where you double the argument here. You double this. And if this is a 2, that would become a 4. If this is a 3, that becomes a 6.
And that's where the 1/2 comes from.
And the 1/2 comes from, yeah, the substitution, the half angle substitution.
Kept skipping that in the videos I was watching.
Yeah. See that cosine to alpha there under the do not erase? If you were to solve for sine squared, you would get, subtract the 1, divide by -2. You get sine squared and then reverse the signs. You would get the 1/2 and you would get 1 minus cosine 2 alpha. And that's what this is. Okay. Actually, so if you do take a test in here, which you will do, that number 16 gives you the half angle form for both cosine squared and sine squared, if you had to do one of those integrals out, which I can't even see me ever asking you, but it's there just in case. Okay. Any other questions on that? Everybody else set? Okay, David.
Could you go over finding the tangent lines again?
There are 2 kinds of tangent lines. One is a tangent to a polar graph at the pole, and you find the equation of that by setting the polar equation r equals 0. Okay, that's one. That's like what we did with this one here. If you set this one equal to 0, this is equal to 0 when theta is 0, and that gives you one tangent to the graph at the pole. And if the next time that the sign is 0 is when its argument is pi. So if you set 3 theta equal pi, and theta is pi over 3, that's 60 degrees. That would give you the other tangent to the graph at the pole. If you need to find the slope of a tangent line, you need to find dy dx. In order to find dy dx, you're going to have to change it to parametric form. Okay? So, do you have a particular example there?
I can pull them up.
Go ahead. Let's do it.
Okay. Well, this is one that involves asymptotes. So you have x squared over 64 minus y squared over 1 equals 1.
Okay. This is not polar. I was talking about polar equations. All right. This is. You can find. This is a hyperbola. Opens left, right. Okay. So what do you want to do here? What is it you want to do? You just tell me. You got a polar graph to find the equations?
Actually, this wasn't the right problem. So,
Okay. Okay, that's all right. If I give you one like this is a hyperbola, which you should know. I may ask you to identify it. What's the orientation? With the hyperbola, the orientation is either left to right or up down. If the x is first, it's going to be left to right. Okay. The center of this is 0, 0. Okay. Go ahead.
Sorry, I just lost that.
That's okay.
Let's find the foci.
Whoa, of what? This?
That's just, I'm reading off one of the weather sign problems.
Okay, foci of what?
Smaller x value.
This equation is what I'm using?
Yeah.
Okay. All right, I'm not going to ask you that on the test, okay, so be advised of that. But here you go, you ready? You've got an a squared is 64, a is 8. The a is always the positive guy. The b squared is 1, so b is 1. And in this, it's the c squared is equal to a squared plus b squared. That's a hyperbolas. So c squared is equal to 8 squared plus 1 squared. C squared is 65. C is the square root of 65. What we have here is this situation. We've got intercepts of 8 and negative 8. Okay, that's a hyperbola. We've got a C of square root of 65. Oh, it's just a little bit past it. Okay, this point right here, this and this one. Let me do this one first. I'll call this the first focus. The first focus would be a negative square root of 65, 0. That would be this point. And the second focus would be the square root of 65, 0. That's this one here. And that's it. What else you got? Questions? Wait, say that again?
What does the b value do?
The b value is 1. This is b squared.
Yeah, no, I know, but where is it?
Oh, nowhere. This is a. The thing is, this is a. What you get when you draw this rectangle.
Oh, right. Okay.
You know, this is the b value here. So that gives you those asymptotes here, the slant asymptotes. Yeah. Nick?
Does that have directors?
No. The hyperbola is a set of points in the plane whose distances, the difference of and whose distances from 2 points, the foci, is a constant. So every point you take on this, if you take this distance minus that distance, is a constant. Okay? The difference in the two distances is a constant. Okay? Yes?
If you were to have a limit on, like r equals 1 plus 2 cosine theta, what are the two numbers? Like, what does 1 do to it, and what does 2 do to it?
Well,
If you could change it.
Here, what it does, because the 2 is greater than 1, it's going to have a loop, okay? Because it's great enough to pull the thing through the loop. Cosine here is got symmetry with the polar axis, okay? If you start at theta equals 0, you're going to get r equals 3. You're going to start here at 3. And what happens is it's going to go this way. It's going to hit here and go through, come out, and go this way, and like this. That's pretty much a perfect limicon, which is rarely seen in the real world. So there it is right there. I would, if I were you, take a photograph of that or something, but no, that's all right. Okay, so what it is the fact that it gives you this distance here. At pi, when theta is equal to pi, cosine is negative 1. You get a negative 1 here. 1 plus negative 2 is negative 1. This point right here would be negative 1 pi. So that difference will give you this distance here, is what it does. But that's not critical. What you should realize in this whole thing is, because it's, first of all, the first thing you realize, it is a limicon. Secondly, because it's cosine, you get the symmetry with the polar axis. Thirdly, because this is greater than this, it does have a loop. That's what you should know. That's the basic bottom line of that. What else you got? Go ahead.
Okay, so I got the problem r equals 3 sine theta, and I need to find the slope, dy dx.
Okay.
The parameter is pi over 3. I'm just wondering, like, the easiest way to...
Well, there is no easy way here. You know, even changing the rectangular is not all that easy. The usual way is to put it in parametric form and then use the chain rule. So I'm going to do it. Okay, you ready for this?
Yeah.
Although putting in rectangular is not that bad, but the proper way is put it in parametric form and then use chain rule. So let's do it. Okay, how do you put this in parametric form? Well, you realize that x is equal to r cosine theta, and that y is equal to r sine theta. Okay? This tells you that x is equal to 3 sine theta. Okay, I'm replacing the r with 3 sine theta. Cosine theta. This one tells you that y is equal to r, which is 3 sine theta, times sine theta. Bless you. 3 sine squared theta. Okay? This is now in parametric form. Okay? This is now parametric form. If you were to do a parametric plot in Mathematica on this thing, where this is the x and that's the y, you'd get this same thing you would get if you did a polar plot on 3 sine, which is that circle. Okay? Has symmetry with theta equals pi over 2, whose diameter is 3. Okay? How do you find the derivative? You find dy d theta divided by dx d theta. Okay? Let's do it. I'm going to have to go to another page because the numerator's complicated here. Okay, you guys ready? Okay, everybody ready? You ready? You sure you're ready? Are you positive? Yeah, okay. So, dy dx is equal to dy d theta. Now, that's y is 3 sine squared. That derivative is going to be 6 sine cosine. Okay? That's dy d theta. Over dx d theta. It's a chain rule. It's first times the derivative of the second plus the second times the derivative of the first. Oh, man. That's what it is. What can I tell you? So what do you got? You got 6 sine theta, cosine theta. What do you have here? You have minus 3 sine squared plus 3 cosine squared. It would be nice if that were equal to 1, but it's not. But you do have something here. Okay? 2 sine theta cosine theta is a double angle form. It's the sine of 2 theta. You've got 3 of those.
Does that only work for 2?
Say that again.
Like you had that 3 sine cosine to start. Could you just say it's sine 3 theta?
Yes. Yes. If you have this, say what you said again, Liam.
So you had originally 3 for the y value,
Yeah.
or for the x value. You had 3 sine cosine theta.
Yeah.
Did you just made that sine 3 theta?
No. No.
It only
No.
works for 2?
No. 2, it only works for 2.
Okay.
It only works for 2. Good question, though, because it looks like it should, given the pattern here, but it doesn't.
Okay.
This is 3 times 2 sine cosine, and 2 sine cosine is sine 2 theta. This is 3 times cosine squared minus sine squared. Write the cosine squared first. And cosine squared minus sine squared is equal to cosine 2 theta. Thank you, Ted. So you got 3 of those as well.
Which is equal to tan 2 theta.
Jump right.
That's just amazing.
Perfect. Okay, sorry. The 3's cancel, and you get tangent 2 theta. Now, it seems to me that you could have done that. If you start with any constant here, sine theta, because we did r equals sine theta, and I'm pretty sure we found it to be tangent 2 theta there too. And if you 3 sine theta give us the same. I think if you start with any constant in front here, your derivative will always be tangent 2 theta, I believe, because these would just cancel out, and you end up with this anyways. I think that's always going to be the case. All right, I'm pretty sure. So, here's our Dean. Yes?
Good morning.
Good morning. Yeah, it's still morning.
I have a question.
Go ahead.
I had to run up and catch you.
Oh, we have math team today, so you could have come in then too.
Oh,
All right.
awesome.
And we have pizza, so you could have had some pizza.
Probably better than lunch rundown.
But you have to do a math problem to do it, to get it.
I can do that.
Yeah, I know you can. All right, go ahead.
I have a student who's in Anne Marie's 078.
So you got it.
I'd like to move him to you.
Oh, okay, fine.
Your web-assisted 8 o'clock class.
Okay, with my,
It's full.
that's okay.
Can you send me an email telling me it's okay?
Sure I can.
So when you get out of here, just send me a quick email telling me it's okay for me to overload by one student.
Got it,
And I'll have the registrar's office move him
got it.
to you.
And I have to talk to you about buying those cables, because we got all kinds of problems buying those little cables from the math department, because they're not sold at WB Mason, and we have to do something else. But that's another story. I won't talk about that.
Yeah.
Because that is, boy, it's an effort. But we can do it.
We can do it.
And I'll take the student.
The issue, that's not the issue. What's going to happen is I'm sure that we are already buying similar cables for one of the other departments, like, the engineering departments, another vendor, so we'll just use the same vendor that we use. For the
Okay, that's
engineering.
fine. It doesn't matter to me.
Yeah, we
But I
can-
know Blanca is having all kinds of problems because she said it has to come from
No,
WB
it
Mason.
doesn't. No, it doesn't.
All right.
No, it doesn't. So
But we'll talk.
We'll find a vendor.
Okay.
Shoot me an email.
All right, we'll do. That's my 8 o'clock Monday, Wednesday, Friday.
Yes.
Got it.
Thanks. What's assisted, right?
Yes.
Okay. Thanks.
Yep.
How do you know?
What?
Am I posting this?
You- I don't know. We'll figure it out. Okay, anyhow, I think it works no matter what there. And it's easy enough, we could prove it. Any other questions? Go ahead, Omar.
It's a question about finding two sets of like running rectangular form to polar form, finding two sets of values, one with the greater R value, one with the less.
Oh, that greater and lesser than thingamajigger? Give me the points.
Sure. Negative 12, comma 5.
Did I do this one before? I did something like this. So you got negative 12, comma 5 in rectangular. Negative 12, comma 5. And we want to put that in R's and thetas. R is clear. It's 13. It's the square root of a squared plus b squared here, or negative 12 squared plus this squared. This is the R. And the theta is equal to the inverse tangent of y over x. That would be a negative 5/12. Okay. So that's one way to express it. Now, and I think, but you got to be careful here. So the inverse tangent of negative 5/12 gives you an angle that's going to be negative. It's going to be in the fourth quadrant. It's going to be over here. So that's what you got to be careful about. And you're going to have to add pi to it. Plus, they say the angle has to be between 0 and 2 pi as well. Yeah. So they want an angle between 0 and 2 pi. This angle is over here. This is the inverse tangent of negative 5/12. Okay. So what you need to do is add pi to that to get you over to here. And that will be one. Okay, so one answer is 13 and pi plus this angle.
So
Yeah, go ahead.
that, the angle where you're starting is where your negative R is, right?
Right here,
Is negative R.
this would be negative r. And that leads us to the second question, which is the minimum value of r. This is the maximum. And the other thing is, take the negative 13, and then if you were to take this angle, that would give you this, what you need. But the problem is,
You're not very far.
the angle's still not between here and here. So now what do you have to do? You have to add 2 pi to it to go all the way around.
Add
So
to it,
that,
bring you back to your
yeah,
original
correct. So Weberstein's going to mark this wrong because,
They want a decimal.
yeah, well, that's true too. But because this angle here is not between 0 and 2 pi. What you're going to have to do is add 2 pi to this.
Okay. I was like mixing up my positive and negative R's.
Yeah, it's easy to do. This problem's kind of weird. Okay, so your two answers are 13 and pi plus that angle. And then a negative 13 down here. This answer works, except the angle is not between 0 and 2 pi. This answer is nice because there's the negative and there's that. And when you have this negative r, it takes it from here and brings it through to the other side, which is where we want to be. But the problem is this angle is not expressed in the way they want it. So add 2 pi to that to that angle to go all the way around to get back to here again. And you have an angle that they need. Those are your two answers, here and here. Wow. Dylan, I'm working like a dog here. All right. Okay. Any others? Yes?
Could you write out the equations along with their forms? Like the ellipse, like that, all that stuff, the parabola?
Yeah, sure, we can do that. Here you go. Parabola. X minus h squared is equal to 4p y minus k. Okay. Circle. And now, obviously the x's and y's could switch, okay? This would be concave up, but a circle, x minus h squared, y minus k squared is equal to r squared. That's a general form. Ellipse. The general form is x minus h squared over a squared plus y minus k squared over b squared is equal to 1. And the hyperbola, x minus h squared over a squared minus y minus k squared over b squared equals 1. Okay. Now, in the ellipse, I should mention that a is greater than b. If it's equal to b, we're back to a circle. The a is greater than b. Always. So if you had a 16 here and a 9 here, a would be 4, because that would be the a over here. Okay? And that matters in the length of the semi-major axis, which has got to be the a, which is going to be the greater than the b. This here, the a is always under the positive one. Okay? Whoever is positive gets the a. Whoever is positive, that's the center to those intercepts, okay? And that's going to be the a. A is underneath the positive. That's basically it. P, you should know, is the distance from the vertex to the focus and the vertex to the directrix. You should know that.
Distance from what?
What's that?
From what? One more time.
On the parabola, the P is the distance from the vertex to the focus and from the vertex to the directrix.
Okay. The directrix is the same as the focus, but
Directrix is a line, focus is that point.
okay. And the same distance from the focus, just marked as a line.
Yeah, yeah, it's the same distance. There, 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 there.
Those are all the lines we have to know for the exam.
Yeah. Yeah. Okay, any others?